Now let's find the solutions of integrals with trigonometric functions, but first let's evaluate this so that you can get a clear concept. You have to find the integral of this particular term with respect to dx. Now, you've not dealt with this before, so very easy way to solve integrals is basically, if you have this term and it has 3 raised to the power under 3 over 2 in the power, you can first, what you have to do is you will have to multiply this term a minus 2x raised to the power 3 by 2 with the derivative of a minus 2x, this term. Now, the derivative of a minus 2x is minus 2 because a is a constant, so the derivative of a is 0, and the derivative of minus 2x is minus 2. Now that you have this, obviously since minus 2 is being multiplied over here, you will also have to divide the entire equation with 2, minus 2, and obviously you can write that down as minus 1 by 2 as well. So now you'll apply the normal power rule that you applied earlier, which is to say that if you have this particular term a minus 2x raised to the power 3 by 2, basically what you'll do is a minus 2x raised to the power 3 by 2 dx and the integral. Basically what this results is as before that it'll always be multiplied with minus 2 dx. Now the result of this is basically a minus 2x raised to the power 3 by 2 plus 1 over 3 by 2 plus 1, and this is what you get basically. And obviously you'll also have to add the constant of integration, so this is just the final result that you get. Now let's move on to trigonometric functions. Find the result of the integral of sine a plus b x dx. Now what you'll do here is you'll apply the same thing. You have sine a plus b into x, and then basically what you'll do is you'll multiply it with whatever is inside the sine term, and that's a plus b. It should be fairly intuitive by now because this is what you did in differentiation. You're just doing the reverse of it. So you'll multiply it with the entire thing by a plus b, and you'll also divide it by a plus b as well, because these two have to cancel out. The original equation has to remain the same in quantity. So now what you can do is you can apply the integral of sine a plus b into x, and basically that just results in minus cos a plus b x. So a plus b are constants, by the way, so that's why. You also have like formulas for this. For example, the derivative of say sine x with respect to x would have been cos x, but the integral of sine x with respect to x is basically equal to minus cos x, which is why we have this negative sign over here. Now once you solve this, this is basically that what you get.